Welcome. So in this lesson, we're going to be working through functions and modeling exercises. So in the following example, we'll see how function notation can be used when applying mathematics in real situations. So let's jump into our example here, and we'll also be using our CAS calculator in this question as well. So make sure you've got that handy. Okay, let's see how we go here. It says, a householder has 6 laying hens and wishes to construct a rectangular enclosure to provide the maximum area for the hens, using a 12-meter length of fencing wire. Construct a function that will give the area of the enclosure A in terms of its length L. By sketching a graph, find the maximum area that can be fenced and also state the domain of A. All right, so let's see how we go here. The first thing that we do when we're given a question like this is just kind of visualize it. So we know that we're dealing with a rectangular enclosure. So let's draw a rectangle like that. Now, the next thing we have is 12-meter length of fencing wire, 12-meter length of fencing wire. So the perimeter is 12 because I've got 12 meters to make this thing. So obviously the perimeter is 12. And can I say, this is normally the part that people find tricky. They don't recognize that the perimeter is this 12 meters of fencing wire. But if you can recognize that, that's almost the trickiest part of this question. So if you can say, hey, I'm making a rectangular enclosure and I've got 12 meters of fencing, that must be my perimeter. If you can do that, well done. Okay. Can I now create an equation from this perimeter? And I can. First, I'm going to label each of these sides. So W and W for the width and L for the length. So therefore, W plus L is going to be equal to the perimeter, which is 12. So 2W plus 2L is equal to 12. Let's leave that equation there for now and move on to the area equation. We know that we're dealing with area because the whole point of this question is we're trying to figure out the maximum area for these chickens. All right, so the area is going to be length times width. But importantly, it says that we want to create a function of the area in terms of the length L. At the moment, this is in terms of both L and W. We just want it in terms of L, so we need to get rid of this W. To do that, we go back to our perimeter equation and we solve it for W. So I'm going to rearrange to make W the subject. So if I do that, I'm going to end up with 2W is equal to 12 minus 2L. So I'm subtracting 2L from both sides, and then I'm going to divide across by 2. So it's going to be W is equal to 6 minus L. So I just divided both of these by 2. I now am going to take this and I'm going to put it into the W spot. So now I'm going to get area is equal to the length times 6 minus L. I now have my area just in terms of L. So my area now, I'm going to come down here because this is the important part because we needed to construct a function. I'm about to do that. My area in terms of L, so A of L, is going to be equal to 6L minus L squared. So I just distributed out that L at the front there. That right there, everyone, is our function. So we've written it in our normal way. There is our function. So construct a function of the area of the enclosure, A, in terms of its length L. And there it is right there, success. Okay, the next thing that we need to do is sketch a graph. To do this, we're going to use our trusty CAS calculator. So hopefully you have it handy. Let's come over here. Let's go here. Let's first just define it on our CAS. So I'm going to go A of L, and then I'm going to go control this, 6L minus L squared. Okay, so I have defined it, and now we can graph it by going control, add page, go to the graph. Now, it's important that if you're ever doing this, if you just go A of L, it's going to become confused because you're using L in the graph section. In the graph section, you have to use X. So just replace it with an X, it still works. So don't freak out that it's not going to work, it still works. So if you ever define your term as anything other than X in the calculator page, and then you come to graph it, just make sure you replace it with an X so you can graph it. Okay, at the moment, the windows aren't great, right? I can't really see it. So if we come here, we go window zoom, we can alter this. We can zoom out Zoom out is okay, but it's not the best way to do it because it's not very accurate. Like this is fine, but sometimes we want to be a bit more accurate. What I would recommend you use is the window settings. So after a while of dealing with these, you'll be able to become better at adjusting the window settings. So if I come here for a second, you can kind of already see what we're going to adjust it to. I really don't care about anything underneath the x-axis. I don't care anything to the left of the x-axis. And there's too much space here and too much space here. If I go menu, window zoom, window settings, I can change my minimum x to, I don't know, -1. My max x, let's go up to 20. My y min can be -1 as well. And my x can be 10. My x max will be 10. So now what you'll see is it's done that for me. And already you can see that my x of 20 is way too big. So I can go back, menu, window zoom, window settings, and instead of going to 20, we can go to 10. So there we go. That's pretty good. So by changing those window settings, you become better at kind of seeing the graph. And the more you do this, the more questions you do, the more you play around with your CAS, the better you'll become at changing those window settings. So it just comes with practice. With our CAS, I know it can be intimidating, but you just got to put in the time to get better at it. Okay, so what are some things that we want to find here? We need to graph this. So obviously we want to find the maximum. There it is. We want to find our x-intercepts. So 0. And you can see that this one goes through 0, but we'll do it anyway. Perfect. So we got our x-intercepts and we got our maximum. As you can see here, the maximum area is 9 and it occurs when the length is 3. Another way we could find this is if we used menu, calculus, the function maximum. So here I could go a of L, whoopsie daisy. So I'm trying to find the maximum of a of L for the L value, and that's going to tell me the maximum area is going to occur when L is equal to 3. And now I've just got one more move here. I'm going to put that into my equation. So a of 3 is going to be equal to 9. And that's exactly what we see here. When the length is 3, I get my maximum of 9 out. Perfect. Don't worry about all these bits on the end here. It's just because my float setting is so large that I'm getting all of it. But the float probably doesn't have to be that big for this one. The float can be accessed here. All right. So having done all that now, let's give this a sketch. So I'm just going to come over here. Let me move this like that. Come down like this. We'll draw our axes. I might come down a bit more. This is my area. This is my length. It goes up. It goes down. This is 6, 0. This is 0, 0. And this right here is 3, 9. Important thing to recognize here is that you wouldn't extend the graph down, would you? Because it doesn't make any sense for the area to be negative. So you don't include these parts here. You label these are your endpoints. This is where the graph is stopping. So it's just important that you recognize that. Okay, so once we've done all of that now, what else do we have to do? It says that we need to find the maximum area and say the domain as well. Well, let's do the domain. The domain's pretty easy. The domain of this, so the domain of A, is simply going to be 0 to 6. So my length can be from 0 to 6. So it's kind of, the domain is all the possible x values, but in this case, it's all the possible L values. So there is our answer right there. And the max area, we already know this, max area is 9. So the max area is going to be 9 meters squared, and it's going to occur when L is equal to 3 meters. Occurs when L is equal to 3 meters. So there is my domain of A. My max area is 9 meters squared, and it occurs when L is 3. I've drawn myself a nice little graph. Hopefully you were able to follow along with the CAS steps there as well. There you go. Hopefully you found this useful.